Hi guys, Miss Green here on this week's Ed Puzzle on earthquakes and using page 11 of our reference table. So we already talked about in class when an earthquake occurs, it sends out different seismic waves, and those seismic waves help us to read and interpret how far away the earthquake is and how severe it is. So earthquakes create seismic waves, and then these waves are recorded by a seismograph. So this picture that you see here on the diagram is called a seismograph. Primary waves, or the P wave, travel the fastest, and the particles move in the direction of the wave. When we played with the slinky in class today, we saw that tight section of the slinky kind of go towards the direction of movement, so that forward motion. These are the first to occur because they are primary, and they are less destructive than their other wave, the S wave. Now the S wave is kind of easy to remember because we have S for the secondary wave because it comes in second place. Because it comes in second place, it's obviously traveling slower, and this one moves from side to side. So when we kind of whipped the slinky up and down, we saw that wave action of it moving up and down like you can see here. And that's the way that the secondary wave moves. Because it does move side to side, it is stronger, which means that these waves are more destructive to our landscapes, to buildings, to what we really associate an earthquake with, which is damage. These waves also can only go through solids. We'll talk a little bit later in the unit about why that's important to remember. So S can only travel through solid, they move side to side, and they are slower. So I have a snippet of page 11 of our reference table here. If you look at the vertical axis, we see travel time in minutes, so how long it takes these waves to travel. And then if you look at the horizontal axis at the bottom, you see the distance from the epicenter. We know that the epicenter is the location on Earth's surface where the earthquake occurs. So where you could stand physically on Earth's surface, and right beneath you is that focus point, right, where the earthquake occurred. So we're going to enlarge a small section of this horizontal axis to take a closer look at the time. We see that each minute, because we know that each of these numbers, 1, 2, 3, 4, and 5, are broken up into minutes, there are 3 segments. So if there are 60 seconds in a minute, and this is broken up into 3, then how many seconds are each of these units? You guessed it correct. It is 20 seconds each. So right here would be 1 minute and 20 seconds. Right here would be 1 minute and 40 seconds. And then instead of 1 minute and 60 seconds, we know that that would make 2 minutes right here. So each of these are 20-second intervals. So what would this time be here? If you said 2 minutes and 20 seconds, you are correct. Okay, now let's take a look at the horizontal axis. When we look at the horizontal axis, we see epicenter, distance, and then something crazy in scientific notation. Anything times 10 to the 3rd power just means that you add 3 zeros at the end. So you take this 1 and you add 3 zeros at the end. That just means that this is actually 1,000 kilometers instead of 1 kilometer. Let's take a closer look at that horizontal axis. We see that between 1,000 and 2,000 kilometers, we have 5 little segments where it's broken up. So if we took 1,000 and we broke that up into 5 different segments, what does each segment equal? You're correct. It is 200 each. So each segment, starting with 1,000, would then be 1,200, 1,400, 1,600, 1,800, until we got up to 2,000 here. So what would this location be right there? How far is that from the earthquake epicenter? If you said 5,400 kilometers, then you are correct. All right, let's take a look at page 11 and try some practice regions problems from there. How long does it take an S wave to travel 5,000 kilometers? So if I look at 5,000 kilometers, then I'm finding that here. And now you have to go up to the S wave. This is a common mistake if you stop at the P wave. You have to continue to the S wave and then go across. So if you got 15 minutes, then you are correct. All right, next problem. The recording station tells us that it took 6 minutes and 20 seconds for the P wave to reach them. How far away from the epicenter of the earthquake must they be? So it took 6 minutes and 20 seconds for the P wave to reach them. So I'm going to look at 6 minutes and 20 seconds, and I find that here. Now again, it's important to remember which wave we're talking about. We have to go over to the P wave, and then how far away is the epicenter? We know that we need to go down. So from there, we're going to go down, being sure to keep a straight line, and that looks like 3,400 kilometers away from the epicenter. Next question. It takes 7 minutes for the P wave to reach Belmore, New York. How long did it take the S wave to reach Belmore? Well, it took the P wave 7 minutes. So I'm going over to my minute side, and I'm looking for 7. And again, I need to go all the way until I hit the P wave, right? So how long did it take the S wave to reach Belmore? So we're not asking anything about epicenter distance here. We want to know about this S wave. So in this case, you have to go up to the S wave and see how long. That's in minutes they're asking for. So we have to go over. Looks like our best answer is 12 minutes and 40 seconds for that. All right, the toughest question yet. A P wave reaches a seismograph station 2,600 kilometers from an earthquake epicenter at 12:10 p.m. According to the Earth size reference tables, what time did the earthquake occur? So we know that a P wave reached the seismograph station at 2,600 kilometers. That is over here at this point at 12:10 p.m. So again, we have to go up to that P wave and find some information about that P wave. Well, we know that the P wave took 5 minutes to travel to the seismograph station. So if it happened at 12:10, they got that reading at 12:10. If a seismograph station got a reading of an earthquake, that means the earthquake had already happened, right? That makes sense. So the earthquake happened 5 minutes before the seismograph station got that reading at 12:10. So what is 5 minutes earlier than 12:10 p.m.? D, 12:05 p.m. is the correct answer. Last problem. I know that there was a 7-minute difference in the arrival of my P and my S waves. How far away from the epicenter must I be? This word is going to be huge. When you see the word difference, that means, this is one of Mr. Jansen's tricks, we need scripference paper, aka scrap paper. You must use scrap paper for problems like this. Okay, you know there's a 7-minute difference between the P wave and the S wave. What we need to do is measure out 7 minutes of difference in between my P wave and my S wave. So, here, I'll use this one. I'm going to start at the very bottom, and I'm going to draw a line up to 7 minutes. Okay, so I'm able to use the magic of the smartboard, but you're going to, with scrap paper, mark off a little area on your scrap paper where you have the 7 and the 0. Do not just put the 7. Make sure you have the 7 and the 0. Then you are going to slide that scrap paper, keeping it straight. We're not bending that or turning it in any way. We're keeping it straight, and we're measuring to see where the bottom of this line is going to touch the P wave and the top of the line is going to touch the S wave. Once you get that, what is the distance away from the epicenter? So try that on your own. What is the distance away from the epicenter? It looks as though your distance from the epicenter is going to be 5,600 kilometers away. So that answer would be 5,600 kilometers away. So remember, the key word here is that if you see the word difference in your question, you need to use scrap paper and do the slide and fit method. We'll practice this in class. See you there.